Assalamualaikum. Kami daripada grup 5 mempresentkan untuk present assignment yang diberi, iaitu control system. Terdapat 4 soalan dan dibahagikan soalan 1, 2, 3 dan 4. Dan saya bagi pada soalan 1, Syatirah untuk present.
Okay.
Question 1.
Question 1. Okay. As a instrumentation and control engineer in research and development branch of a company, your client would like your expertise to propose a design and instrumentation system used in controlling the elevator as figure 1. From this, we can calculate the overall block diagram, data output over data input, label each input and output with appropriate signal. Okay, from this figure 1, we can get the overall block diagram. From this, we can reduce using reduction system. G2 times with G3 because the block is in series component, and then we feedback it with H1. So the final for the block diagram, so we can get this, the output and input. CS over RS is equal with data output over data input. Is equal G1, G2, G3 over 1 plus G2, G3, H1 plus G1, G2, G3. So when we get the answer, we can substitute with the value from the figure 1. The G1 is negative K1, G2, G3 and others. We substitute it into the equation, so we can get the data output G1, G2, G3 is equal with the value data input. Also we can get from the figure, value from the figure 1. So second, discuss the function for all elements of electrical mechanical system involved. From the figure 1, we can conclude that the pitch command is the input, so the pitch command acts as a reference signal. The output is the pitch, which acts to control the variable signal. The controller is the pitch gain, which monitor and affect the operational conditioning of a given dynamical system. The actuator is the elevator, is a mechanical device for a moving and controlling a system. Plant process is the vehicle dynamic, which part of machine that function together to perform the elevator. Lastly, the sensor, which is pitch rate sensor, is a measurement of the output value. Last for this question 1 is possible modification and upgrades. The modification and upgrades are needed to change as necessary to help people enter the high building. Firstly, the healthy movement and sudden stop of the building elevator are probably caused by an old controller. Controller typically lasts about 25 years and often the major component replaced during an elevator upgrade. Therefore, the newer microprocessor-based controller, which is variable frequency drive VFD. This VFD can smooth, fine-tune cab movement, starting slowly and then maintain a steady speed until the cab comes to a gradual stop. Because The older controller, which is elevator like VFD, can result unpredictable rides. Next, the elevator cab can be upgraded with the call button panel, must be at a wheelchair accessible height and have a race number display. The elevator must have an auditory aid such as a bell or a recorded voice indicating the elevator direction and floor location. It can help the blind people to know their arrival. The exhaust fan in the ceiling, educate lighting and a dedicated fire call telephone are needed equipment to install in the elevator. So next for this question 2, Muhammad Ahmad Faidi will be present.
So for question 2, discuss one real-life example of K-range in Bruce Hurwitz tendency criterion. For example, a completely integrated six-leg micro-robot system, the leg designed to provide maximum dexterity. Legs also provide unique sensory system for environmental interaction. It is equipped by with a sensor network for 12 different types. It that include 150 sensors of 12 different types. The legs are instrumented so that can be determined the layout of the terrain, the surface texture, hardness, or even color. The gyro, the gyro stabilized camera and rangefinder can be used for gathering data beyond robot immediate reach. This robot can perform dynamic motion. So this robot is used the K range with criterion. Question 3. Explain standard test signal and derive equation of steady state error constant Kp, Kv, and Ka. Standard test signal. The test signal has 5 steps, which is impulse, and the function is to observe transient response modeling. Number 2 is step to observe transient response steady state error. And number 4 and 5, RAM and parabola has same function, which is to observe steady state error. And lastly is sinusoid to observe response modeling steady state error. Sinusoid is the best test signal. Then the derivation of position error constant Kp. Position error constant equal to lim s equal to 0 g h. Assume unit step rs equal to 1 over s. Then limit s to 0 s multiplied by r over 1 plus g s h s. Then we substitute the rs with 1 over s, and we cancel it. Then we get lim s to s to 0 equal to 1 over 1 g over s. Then we convert it, it get ESS equal to 1 over 1 plus Kp. For velocity error constant Kv, which is lim s to 0 s multiplied by gs multiplied by hs. Assume unit RAM, which is the rs, 1 over s squared. ESS equal to lim s to 0 s times rs over 1 plus gs hs. We substitute the rs with 1 over s squared. Then we cancel the s squared with s. Then we can get 1 over lim s to 0 s gs over gs times hs, which is we can get ESS equal to 1 over kV. And the last one is the acceleration error constant Ka, which is lim s to 0 s squared times g s hs. We assume unit parabolic, which is a ps over ps equal to 1 over s cube. ESS lim s to 0 s times ps over 1 plus gh. We substitute the ps to 1 over s cube. We cancel the s with the cube, and we can get 1 over lim s to 0 s square gh. Then we can get ESS 1 over KA. Then, explain the function of natural frequency and damping ratio in second order system. Natural frequency, omega n, and damping ratio are two quantities that can be used to describe the characteristic of the second order transient response, just as time constant describe the second order system response. The damping ratio, it gives an idea about transient response, and the natural frequency, it gives an information on system response. Next, for question 4, Muhammad Faizuddin will present.
Assalamualaikum. Question 4. I need to solve the consider a unity feedback system with the open loop function GS as follow. Okay, first step 1, find the open loop transfer function GS HS. First, you must to substitute the k 10k substitute with 1000, and then the s must be substitute must change the s, convert Laplace to frequency response. The s must convert Laplace to frequency response. After that, after convert all the s into the frequency response, you need solve the equation, and then after get the equation, you must create a approximation table. Approximation table have a factor, magnitude slope and phase slope to plot both diagram. Okay, after finish create the table, you can plot the both diagram using two ruler. Okay, before that, you must find the starting point for magnitude and phase plot. To find the starting point, you must substitute value of s into 0.1 because it nearest to the 0. And after find the starting point, you can plot the graph. And the graph have and the graph you need semi-log graph paper and two ruler. So the graph have magnitude and phase. On left hand side is a magnitude and the right hand side is a phase. And first step to plot the graph, you must make you put letakkan macam dia punya untuk rujukan untuk nak buat graf nanti. Contohnya yang first start tu nak kena buat rujukan 3 line atas kali tu kat penjuru atas tu. Lepas siap tu baru start buat plot graf semua dan letakkan satu-satu. Dia ada dalam graf ada phase plot dengan gain plot. After finish get the phase plot and gain plot, we can find the GM and PM. It is a phase margin and gain margin, and you can show the stability of the system. And at the end, my calculation got the system is not unstable because all the margin, phase margin and gain margin is negative. And that's all. Thank you from me.